This question asks you to compare halvingrandom.searchcv and randomizedsearchcv in Sklearn. I'm focusing on how enabling successive halving changes the hyperparameter optimization process. Think about how each algorithm searches for the best model parameters. This is a scikit-learn function. It randomly samples different combinations of hyperparameters from a defined grid. I then evaluate these combinations and pick the best performing one. It doesn't adapt its search based on the results. It just keeps picking random samples. This is another scikit-learn function. This is similar to randomizedsearchcv, but it uses a more efficient strategy called successive halving. I start with many models, evaluate them, and then remove the worst performing half. I repeat this, evaluating fewer models each time but dedicating more resources to those that remain. This statement is false. Neither halvingrandom.searchcv nor randomizedsearchcv guarantee finding the absolute best hyperparameter combination, the global optimum. They are both heuristic search methods. They try their best, but there's no guarantee they'll hit the very best solution. The hyperparameter space might be complex, leading to local optima, peaks that look best in their vicinity, but are not the true best. This is also false. Both involve an element of randomness, so the results may differ between runs. halvingrandom.searchcv is usually more efficient in the sense that it evaluates fewer models, but it doesn't always yield a better model. This statement is true, because halvingrandom.searchcv removes poorly performing models. It usually evaluates significantly fewer models than randomizedsearchcv for the same overall budget or iterations. This statement is true. randomizedsearchcv uses purely random sampling. halvingrandom.searchcv, however, uses successive halving. It's a different search strategy. This refers to the core strategy of halvingrandom.searchcv. I start with a large set of models, evaluate them, and discard half that perform poorly. Then, I repeat. This process continues until some stopping condition is met, making it far more efficient than a simple random search. This is the strategy used by randomizedsearchcv. I simply pick random combinations from a defined grid of hyperparameters. It's a straightforward but often less efficient way to explore the hyperparameter space. This is the overall theme of the problem. We're comparing two methods for finding optimal hyperparameters for a model, randomizedsearchcv and halvingrandom.searchcv. This section highlights the key differences between randomizedsearchcv and halvingrandom.searchcv, which are based on their distinct approaches to exploring hyperparameter space. The key difference lies in how they select and evaluate models. I see this line describes the core of halvingrandom.searchcv. It starts with many models. After a test run, I eliminate half the worst performing models. Then, I increase the computing power given to the remaining models for a more thorough evaluation in the next round. This process repeats, similar to a tournament where weaker competitors are eliminated at each stage. Pretty efficient, right? This is a more general statement about comparing different approaches to hyperparameter optimization, specifically contrasting randomizedsearchcv with halvingrandom.searchcv. This line simply names the standard scikit-learn algorithm that explores hyperparameter space through random sampling. It's a baseline method which I will compare halvingrandom.searchcv against. This explicitly names the algorithm being studied, which uses successive halving, a more sophisticated technique than simple random sampling. This is the smarter algorithm which I am highlighting throughout this question. This question asks you to compare having random search CV and randomized search CV. I want you to consider how using _enable_having_search_CV equals true changes the way the algorithm searches for the best hyperparameters for a random forest classifier. We assume both searches run long enough to explore the parameter space adequately. This statement is true. Having random search CV uses a clever trick. It starts with many models and repeatedly removes the worst performing half. This means it checks far fewer models than randomized search CV, which tries random combinations without this intelligent pruning. I'll use an analogy. Imagine searching for treasure on an island. Randomized search CV checks random spots. Having random search CV systematically eliminates less promising areas after each search round, leading to more efficient exploration. This is also true. Randomized search CV just randomly picks hyperparameter combinations, while having random search CV uses a method called successive halving. It's like a race where only the top performers at each stage move on to the next round, making the search far more efficient. This statement is false. Both algorithms rely on randomness, and which performs better depends on several factors. Although having random search CV is usually more efficient, there's no guarantee it always finds a better model than randomized search CV. This is false. Neither algorithm guarantees finding the absolute best hyperparameter combination. They are both heuristic methods that might get trapped in a local optimum. A good solution, but not the very best one. This question asks you to compare two hyperparameter optimization techniques in scikit-learn. Having random search CV and randomized search CV . I want you to understand how they differ in their search strategies and efficiency. The key is to know that having random search CV uses successive halving, a more efficient approach than the purely random sampling of randomized search CV . This statement is true. Having random search CV cleverly reduces the number of models it needs to test. It starts with many models, then throws away the worst performing half after each iteration. This iterative pruning saves a lot of computation time. Randomized search CV on the other hand, just tries random combinations and doesn't do this efficient pruning. This is also true. Having random search CV uses the successive halving strategy, which I already explained. Randomized search CV uses a simple random sampling strategy. They are distinct methods. This statement is false. Neither method guarantees finding the absolute best hyperparameters. Both are heuristic searches. They could get stuck in a local optimum, missing the true best solution. It's like searching for the highest point on a mountain range. You could get to a peak, but that doesn't mean you've reached the highest peak in the whole range. False. While having random search CV tends to be more efficient, it doesn't guarantee a better model every time. Randomness plays a big role in both methods, leading to variable results. I see having random search CV as a clever algorithm. It starts with many models and, after a trial run, it throws away the worst half. Then it does it again and again, keeping only the top performers. Each round, the survivors get more resources, like more computing time, to improve even further, until it reaches a set limit. It's like a survival of the fittest competition for models. This is the core strategy of having random search CV. I think of it as a race where the slowest runners are eliminated at each checkpoint, while the remaining racers get more resources to improve their speed. It's a systematic way to eliminate less promising solutions early, leading to more efficient exploration of model possibilities. This refers to the process of repeatedly removing underperforming models in having random search CV. It's like a gardener selectively removing weak plants to allow the stronger ones to thrive. This iterative removal is what makes having random search CV so efficient. This question focuses on the differences between having random search CV and randomized search CV in finding the best machine learning model for a particular problem. I'd like you to consider how both approaches differ in their effectiveness. Randomized search CV, on the other hand, is a simpler approach. Imagine it as throwing darts at a dartboard. It randomly selects model parameters and sees how well they perform, without any strategy of eliminating poorly performing models. It's less efficient than having random search CV, especially for large search spaces. This is the overarching comparison between two techniques to find the best hyperparameters for a model. It focuses on the relative advantages and differences between a method that strategically eliminates poor performers, having random search CV, and one that randomly explores, randomized search CV. I wouldn't say that, while often better, it is not guaranteed that having random search CV will always outperform randomized search CV. Both use randomness, therefore, results can vary between different runs. This statement is true. The iterative pruning in having random search CV means it tests fewer models than a comparable randomized search CV before it reaches a conclusion, leading to better efficiency. This is also true. Having random search CV uses successive halving, a more focused approach, while randomized search CV simply tries random combinations. These are distinct strategies. This statement is false. Neither algorithm guarantees finding the absolute best solution. Both can get stuck in a suboptimal, local optimum, so they don't necessarily find the very best possible solution. They're great techniques, but not perfect. I'm comparing two methods for finding the best settings, hyperparameters, for a machine learning model. Having random search CV and randomized search CV. Think of it like searching for the perfect recipe. Randomized search CV tries random combinations, while having random search CV is more strategic, discarding bad recipes along the way. This question tests your understanding of how having random search CV differs from randomized search CV. We're evaluating 4 claims about their behavior. I'm outlining the core difference between the two search strategies. Randomized search CV works by randomly selecting settings from the possible options and testing them. It's like throwing darts at a dartboard blindfolded. It might find a good solution, but it's not very efficient. Having random search CV is smarter. It starts with many settings, tests them, and eliminates the worst half. Then, it repeats with the remaining settings, gradually focusing on the most promising ones. Think of it like a tournament where the weaker players are eliminated at each round. This is far more efficient.